All right, plan for this recording is to talk through this idea of a matrix and how we're going to use a matrix to solve a system of equations. So that is our plan. First thing, what is a matrix? A matrix is simply a way of storing information that I can use to solve some other problem. A matrix is similar to a spreadsheet in that it has rows and columns, and a spreadsheet stores data. You can make equations out of spreadsheets and so on. You can't really do that with a matrix, but we can use a matrix to solve other problems, which we're going to talk about later in this recording. So what is a matrix? It's simply a way of storing data that I can use to solve other systems or other equations or other questions. When we name a matrix, we typically name it based upon its dimensions. Rows first, columns second. So if I look at my matrix here, I have a few extra little marks in there. So if I look at this matrix here, we have rows on the side, we have columns on the top. So on the side there are 2 rows, and on top there are 3 columns. So this matrix is said to be a 2 by 3 matrix. 2 rows, 3 columns. This matrix would be a 3 by 1, 3 rows, 1 column. And the last one would be 1 row, 3 columns. So a matrix is named sometimes by a letter, but a lot of times you'll talk about the matrix based upon its dimensions. Rows by columns. All right. Now let's look at how do I use this matrix to solve a system of equations. So my first step is to translate this system of equations into a matrix. Okay, there's a couple different ways of doing that. We're going to look at tonight how to write a augmented matrix. Okay? So the first step in doing that is to write down what's called the coefficient matrix. Coefficient matrix is what it sounds like. It's a matrix made up of all the coefficients. So if I look at the left-hand side of this equation, notice both of these equations are in the same basic order. X's, then Y's, then equals, then a number. That has to be true before I can translate or write my coefficients into a matrix. They must be in the same order. All the variables on one side in the same order. So now I just simply write down the coefficients. And one way of looking at that is I simply make a matrix out of this and I get rid of all my variables. So the 1 in front of each of those x's and y's becomes a 1 here. I have a 3 that goes into the second row, first column, and there's a -1 here that goes there. So basically you drop the variables and you write down the coefficients. And I have my coefficient matrix. Next thing, on the right-hand side, there's no variables hooked to those numbers, so they're called constants. They can't change. And so I make a matrix out of those constants. And finally, I make an augmented matrix by putting them together. So I take the 1, 1 coefficient matrix, 3, -1, draw a line down here representing kind of like the equal sign. It's separating my 2 matrices, my coefficient matrix and my constant matrix. The notation for a matrix is a squared off bracket, not a parentheses, it's a bracket symbol. So that represents this is a matrix. And now I have that system of equations represented by an augmented matrix. There's other ways of writing that in matrix form, but this is the most common, and this is the one we're looking at right now. Okay? Or in this course. Next step. I'm going to use this matrix to solve that system of equations. And when I'm done, at least done using the matrix, I'll have 1 in the first row, first column. I'll have a 0 here and a 1 here. And the rest of the entries will come out to be whatever they come out to be. Okay, but my goal is to get 1s here and a 0 here. That's what my goal is. So on the right-hand side over there, I've written down the steps that we use to make that happen. Okay, so first step, after it's already written into the augmented matrix form, my first step to solve that would be to make the entry in row 1, column 1 a 0. This number right here needs to be a 0. It is. Sorry, I said that wrong. It needs to be a 1, and it is. Next step, make the entry in row 2, column 1 a 0. This entry in row 2, column 1 needs to be a 0. To do that, I'm going to use the first row. I'm not going to actually change the first row, so let's just rewrite it, because I'm going to still keep that first row the way I want it, because it has a 1 in the spot I want a 1. But I'm going to use that matrix now to cancel the second, or that entry that's circled in blue there. Let me get rid of that blue. I want to get that to be a 0. So, how do I do that? I'm going to, just like when we did elimination technique, when you've done systems of equations in the past, and you did this elimination technique, you multiplied one of the equations by something and added it to the other equation. Remember, these are like equations. These rows came from equations. So I'm basically going to use that thought process. I'm going to multiply this first row by a -3. Why? Because if I have this being a -3, a +3 plus a -3 will give me a 0 in that entry. But just like back when we solved using elimination, if I multiply one entry of that row by a number, I have to multiply every entry and add them all together. So here's what I'm going to do. I'm going to multiply every entry in the first row by -3. -3 times 1 is a -3. -3 times another one is a -3. -3 times 5 is a -15. And now I'm going to add these entries together. +3 plus a -3, 0. -1, -3, -4. +3, -12. Sorry. +3, -15, -12. Next step. Sorry, step 2 is done. Next step. To make the entry in row 2, column 2, 1. So to make an entry 0, I add things together. To make an entry 1, I divide whatever needs to be 1 by itself. The -4 needs to be a 1. I divide that entire row by a -4. Leave the first row alone because it already looks like what I want it to look like. It already has a 1 in the first entry. Second row, divide everything by -4. 0 divided by -4, 0. Something divided by itself. -4 divided by -4, 1. -12 divided by -4, 3. Step 3, done. Step 4, convert this back into a system of equations. So remember what these represent. These are coefficients of x, of y. Remember I said this is kind of like an equal sign, and this is my constant. So that first row says x plus y equals 5. Second row says 0 x's plus 1 y equals 3. I now know what y is. Y is equal to 3. So step 5 says use back substitution to solve. I'm going to substitute what y equals back into the first equation and solve for x. So I take the y and plug in 3 for it. I subtract 3, and I know x is equal to 2. Now, that may seem like a big, cumbersome process when you have other techniques that you've learned in the past, like elimination and substitution and graphing. But matrices are pretty powerful, especially when you start putting things onto the calculator, which at some point in time you may do in your math career. Okay, so it is important that you see these matrices. Let's try another one. At any point in time when you feel comfortable, hit pause, cruise through the steps, get as far as you can. When you get stuck, come back and join us. So before, remember how I had step 1, step 2, step 3, and so on? That was when it's already in augmented matrix form. So my first step before I even get to that is let's write it in augmented matrix form. So I have a 2, a -1, and a 4. There's my first equation put into a matrix. Second equation, I have 1x, I have a positive 3y, and I have a 9. There's my second equation put into augmented matrix form. Now, I need to make the coefficient, not the coefficient, I need to make the first row, first column a 1. I need to make this number right here a 1. Let me show you a trick. Was there any reason why the second equation had to be second and the first equation had to be first? Meaning, was there any reason why I couldn't do this? Not that. Sorry, my smartboard jumped on me. Is there any reason why I couldn't do that? And put the second equation in the first position and the first equation in the second position? Meaning, is there any reason why I can't take this row, it's not going to let me do it, and rewrite it and put the 1, 3, 9 on top and the 2, -1, 4 on top? There was no magical order in which equation was written on top and which equation was written on bottom. So what I noticed is, there's a 1 sitting there. It would sure be nice if that was sitting right there. And so I did what's called a row swap. We just swapped the rows. And what that basically means is we swapped the equation like I did on the smartboard there. We just swapped the order. We didn't change anything. We just swapped the order. Now I have step 1 completed. Step 2 was to make the entry in row 2, column 1, a 0. We did that by multiplying the first equation by something, adding it to the second equation to get it to cancel. Let's rewrite the first equation because we're not going to mess with that. I'm going to multiply the first equation by a -2, so it's the same number but a different sign as the number I'm trying to get rid of. I need to multiply the 3 by a -2, and I need to multiply the 9 by a -2. Add the numbers I just found to the second row. -2, +2 is 0. -6, -1, -7. -18, +4, -14. Step 2, complete. Step 3, make the entry in row 2, column 2, a 1. Remember, to make an entry a 1, we divide everything in that row by itself. So leave the 1, 3, 9 alone. Divide everything in row 2 by -7. 0 divided by -7 is -7. -7 divided by -7 is 1. -14 divided by 7 is 2. that always has to happen, that you end up with a 1 in this entry, a 0 in this entry, and a 1 in this entry. Okay, that was the whole point of doing the matrix. Convert back to a system of equations. That was 1x plus 3y equals a 9. We have 0 x's plus 1y, don't really need the 1, equals 2. I know what y is. Y is equal to 2. My goal is to find x and y. I know y. I'm going to substitute what y equals into the first equation and solve. So I know x and I know y. All right, let's try another one. Made it a little harder. Again, if you think you got it, hit pause, give it a try. When you're done, come back and join us. All right. First step, make the entry in the first row, first column spot a 1. It's not a 1. So I looked at the second equation. Is that one a 1? No, not lucky this time. It wasn't a 1. So I have to deal with it. How do I make a number a 1? I divide everything in that row by itself. Oh, sorry. Need to make my matrix. Put the coefficients down, put the constants down. Now divide everything in the first row by itself. First row, first column's position is now a 1. Step 1 is complete. I'll go ahead and rewrite the second row just so we don't get confused. Next step, make the second row, first column spot a 0. Make this number here a 0. How do I do that? I multiply the first row by something so that when I add it together, it cancels. What do I need to multiply the first row by? Basically, it's going to be the same number but different sign. I need to multiply by 3. 3 times 1. I'm going to get rid of that arrow because I want my number to be put right there. 3 times 1 is 3. 3 times 2/5 is 6/5, right? 3 over 1 times 2 over 5, top times top, bottom times bottom. And 3 times a -5 is a -15. Add these together. -3 plus 3 is 0. 6/5 plus 2. Common denominator is a 5, so this becomes 10/5 plus 6/5, which is 16/5. So this here is 16/5. -1, -15 is a -16. Step 2 is done. Step 3, make the coefficient, or make this second row, second column coefficient number equal to 1. I do that by dividing everything in that row by itself. 0 divided by 16/5 is 0. 16/5 divided by 16/5 is equal to 1. See how well we remember our fractions. -16 divided by 16/5. When you divide by a fraction, you multiply by the reciprocal. So -16 times 5 over 16. Multiply by the reciprocal of whatever you're dividing by. Make that 16 a fraction by putting it over 1. 16 and 16 cancel. We're left with a -1 here. -1 times 5 is a -5. Step 3 is done. Step 4, convert this thing back into a system of equations. The coefficients are coefficients of x and y. I have 0 x's plus 1 y equals negative 5. I know y is a negative 5. Take that negative 5 and substitute it back into the first equation for y. Multiply. Make a negative 5 a fraction by putting it over 1. The 5's cancel, and I get a negative 1 on top. So I end up with x minus 2, right? Because 2 times a negative 1 is a negative 2. Divided by 1 ends up with just a negative 2. Equals a negative 5. Add 2 to both sides, and x equals a negative 3. And I've got my 2 variables. All right. Let's take this one more step. Let's do a system of 3 by 3s. Process is the same, a little more involved. Okay, a lot more involved. But the process is the same. Remember when we had, I'll just put down something here. We have 1, 5, 7, 2, etc. We wanted this to be a 1. We wanted this to be a 0. We wanted this to be a 1. And we didn't care what was here. That's for a 2 by 2 that's been augmented into a 2 by 3 matrix. Now we have a 3 by 3 that's being augmented into a 3 by 4. And I want 1s on the diagonal. So I want 1s coming down here and 0s here. And it doesn't matter what goes here. So see how we have 1s on this diagonal and a 0 in this entry spot? Same idea. We have 1s on the diagonal. And we have 0s to the lower left-hand corner of it. We don't care what's over here. Whatever happens over on the right-hand side happens. So, in general, we're going to start from the upper left-hand corner. We're going to make this a 1. Then we're going to make this a 0, this a 1. And we don't care what's over here. Then we're going to make this a 0, this a 0, and then that a 1. So we start here and work our way down and across. All right, let's try one. So first step, make the entry in the, make our matrix. Almost forgot that again. All right, my coefficients down, 3, negative, 2, 3, negative 3. Next, we have 1, 1, 1, 4, 1, negative 4, 2, negative 9. All right. Now, we had the trick we had before. We have something called row swap. My first entry that I want to be a 1 isn't, but I notice that the row below that has a 1, and the row below that has a 1. So I have some options. I could move either one of those rows around. Okay? And if I were to do this problem, I would have noticed that at the very beginning and just wrote it right the first time, save myself some writing. But that's all right. Let's just swap the first 2 rows. All right? So now step 1 is done. Step 2, make the 3 a 0. How did we do that? We multiplied the first row by something to get them to cancel. Rewrite the first row. I'm going to multiply the first row first by a negative 3 and do every entry by negative 3. Okay, I'm going to leave the bottom row alone for right now. Okay, so negative 3 times a negative 3 times 1 is a negative 3. And here's where it gets tricky. You can either write everything off to the side, so I'll rewrite my row off to the side, and then I'm going to rewrite what I get when I multiply by products. So I get negative 3, negative 3, negative 3, negative 12. Add those together. Positive 3 plus a negative 3, 0. Negative 2, negative 3, negative 5. Positive 3, negative 3, 0. Negative 3, negative 12, negative 15. Okay? Let's go down. Multiply. I'm going to get rid of this. We could have worked with that negative 5 and the negative 15 now, but I can also just take care of this one while we're at it. Not meant to be blue. We can take care of this one while we're at it. So let's multiply everything in row 1 by a negative 1 this time instead of a negative 3. So I'm going to change this. I'm going to multiply everything by a negative 1. Why? So when I add it to the third row, the 1's cancel. So again, I'll rewrite that top row. I have, I'll rewrite the third row, sorry. 1, negative 4, 2, negative 9. Multiply everything in the top row and rewrite it. You may not want to rewrite. That might be too much rewriting. It might get too confusing. Just be organized as you do this. Adding these two equations or these two rows together, I get 0. I get negative 5. I get 1. I get negative 13. Okay, so I rewrote this row here, and then I multiplied the first row by whatever I needed to multiply by to get those first entries to cancel. All right, let's work our way across now. So remember, the goal was to get 1s down the diagonal and 0s everywhere else. We started with the first column, and we made that the way we wanted it. 1, 0, 0. Next step. Let's make this entry a 1. Leave the first row alone because it's already what we want it to be. Remember, from a 2 by 2, to make something a 1, we divide everything in that row by 1, or by itself. So I have 0, 1, 0, 3. Divide everything by negative 5. Rewrite this row here, because we're not going to do anything with it right now. Okay? Looking good so far. I have 1s on the diagonal, and I have a 0 right here. I need this negative 5 to be a 0. Remember, I used the row above it to cancel it. So I need to multiply this row by 5 and add it to this row. Rewrite the top because we're not going to use it. We're not going to do anything with it. I'm going to multiply this row by 5. So 5 times 3 is 15. 5 times 0 is 0. 5 times 1 is 5. 5 times 0 is 0. Add these two together. I get 0. Add these two together, I get what I wanted, 0. Add these together, I get 1. Add these together, I get 2. Okay, whoops, I forgot something in there. I forgot my middle row. Let's slide that down. And I have my middle row of 0, 1, 0, 3. That was the third row. We get it? We did it. We got 1s here, and we got 0s everywhere else. Next, we're on step 4. Convert it back into a system of equations. So we have 1x plus 1y plus 1z equals 4. I have no x's plus 1y, which I don't really need here, plus no z's, so I don't really need that either, equals 3. I have no x's plus no y's plus 1z equals 2. Wow, that was kind of nice. Look what I have. I know that y equals 3. I know that z equals 2. I can substitute that back into the first equation and find x. Find like terms. Subtract 5, and I get a negative 1. So I have my 3 variables, x, y, and z. All right, sorry, this recording is taking a while. You have to practice one semi by yourself now that you've seen it. Hit pause if you can and go as far as you can, and then come back and join us. All right, I will try to go slow, but yet again making the assumptions that you've seen this once, and we'll go from there. So my first step, remember how we had a 2 by 2 and I said if I were to rewrite this, noticing that I have a 1 right here, instead of writing it the wrong way first, I'm just going to swap rows right now. I'm going to put the 1 in the first row, first column spot like I know I want it to be. So I write the coefficients down of the second row. Okay, so basically I just took this row and I moved it up here. Totally fine. Okay, next thing. My coefficients of the top row, I'll move into the second spot. And the coefficients of the last row, I'll leave in the last spot. Okay, and I have my augmented matrix. Okay, next step. I want to rewrite the first row. So I'm going to do 1, 3, negative 4, 13. Okay, I want to use this 1 to cancel the 4 and to cancel the 3, one at a time. Let's cancel the 4. And the middle row is the messiest one because there's really nowhere to write your multiplication. So I'll use a different color to show what I'm doing. I'm going to multiply the first row by a negative 4. Negative 4 times 1 is a negative 4. Negative 4 times 3 is a negative 12. Negative 4 times negative 4 is 16. Negative 4 times 13 is a negative 52. Okay? Next step. Combine the new green row I just wrote with the second row. I'm going to combine these two. And that is my new second row. Negative 4, positive 4 is 0. Negative 12, negative 2 is a negative 14. Negative 1, positive 16 is 15. Negative 52, negative 5 is a negative 57. Okay, next step. Those are going to be some messy numbers. Next step. We are going to get rid of my mess I've got. And this is where you really need to be organized. If you have a nice eraser like mine right here, it might be helpful. Or like I did the first time, you can simply rewrite the row somewhere else. All right, so this second row has been taken care of. I want to make this go away. I want that to be a 0. What do I have to multiply the 1 by to add to 3 to make it a 0? A negative 3. Bottom row is kind of nice. I have a place to put that. Multiply the top row by that number. Add that to the third row. Negative 3, positive 3 is 0. That's what I wanted. Negative 9, negative 1 is a negative 10. 12 minus 3 is 9. Negative 39, 0, negative 39. Next. My middle row, I want this to be a 1. And here's where the mess begins, or the fractions begin. So I'll come down here, rewrite my first row, 1, 3, negative 4, 13. Divide everything in this row by negative 14. Negative 14 divided by negative 14 is 1. 15 divided by negative 14 is 15 divided by negative 14. Not much we can do about that. Negative 57 divided by negative 14. I'll drop the negative sign, and I get 57 divided by 14. Whoa, that was a mess. All right. I'm just going to rewrite the bottom row to help us. I won't skip any steps. All right, so that's what we have so far. Now, let's rewrite the top row because we're not going to touch it. Second row, I'm not going to change it. I'm going to use it, but I'm not going to change it right now anyways. All right, I need to use this 1 to make this go away. What do I multiply that second row by in order to add it to negative 10 and make it go away? A positive 10. 10 times 0, 0. 10 times 1, 10. 10 times 15 over negative 14. 10 over 1 times 15 over negative 14. Let's reduce. 5 goes in, 2 goes into here 5 times, goes into here 7 times. 7 times 15 is 75, right? So I end up with 75 over negative 7. Multiply 10 times this one here, and I get 10 over 1 times 57 over 14. Again, we get a 5 and a 7. 5 times 57, if my math is correct, is 285 over a positive 7. Whoa, these are some messy numbers. Sorry. Add them together, and I get 0. Add that together, and I get 0. We are testing your fraction abilities. I didn't want to do that. Testing your fraction abilities. All right, so let's jump off to the side. I'm adding these two things together. You can see how it needs to be organized. I'm not sure I am. So we have, I'm going to put the negative on top. We have a negative 75 over 7. Common denominator. What's my common denominator between 1 and 7? This needs to be a 7, right? That already is a 7, so I'm going to leave it alone. 7 times 9 is 63. So I end up with a negative 12 over 7. Oh, that wasn't so bad. Negative 12 over 7. Next thing, we have a negative 3 plus 285 over 7. Common denominator is a 7. This one already is a 7. Nope. This needs to be multiplied by 7, so it's a negative 21. And I get 264 over 7. Whoa. Okay. Next step. Get rid of all this mess so I can recopy some stuff down. Rewrite the first row. I'll spread it out a little bit so we have some room. Rewrite the second row. Right? So I'm not going to do anything with that right now. And I need to make the coefficient in this spot. I need to make the negative 12 over 7. I need to make that a 1. How do I make that a 1? I multiply by the reciprocal, correct? So I multiply everything here by the reciprocal, because that's when you divide by a fraction, you multiply by the reciprocal. So this becomes a 0, this becomes a 0, that becomes a 1. I divided every one of these entries by negative 12 sevenths. So when I take 264, over 7, and I multiply it by the reciprocal, 7's cancel, and I get 264 divided by 12, but it'll be negative. Does that happen to come out nice and neat? 264 divided by 12. Ah, nice. We caught a break. 22. Z is 22. Okay? Did I add that right? I'm going to double check my math here. Hit pause for a second. Okay, I found the mistake. I knew that 22 was kind of big. I wrote down the wrong number. So right here I wrote down 3 instead of 39 because that's what it was before. Back up here was a 39 and I just transferred the number down wrong. So if I find a common denominator, the 57 over 14 is excuse me, still reduced down to 285 over 7, and then the negative 39, making that a common denominator, gives me a negative 273 over 7. And when I work that out, I get 12 over 7. So this is gone. And I get a much nicer number down here. At 22. So my steps are still the same. When I divide the negative 12 over 7, whoops, wrong button. When I divide the negative 12 over 7 by negative 12 over 7 to make this a 1, I divide this by negative 12 over 7, and something divided by itself is 1, and that comes out to be a negative 1. All right, so now remember our steps. Our next step is to convert this back into a system of equations. And I have, on the first line, I have 1x plus 3y minus 4z equals 13. Remember, this is my kind of my implied equal sign, or the place where the equal sign goes. And I get y. I can put that negative sign wherever. Whoops, these are z's. And that last line, I get z equals negative 1. So I have z. Let's go back and let's plug in. So I have plug in that second equation. I have y minus 15 over 14. Multiply that by negative 1 and it becomes plus 15 over 14. Right? Multiply this negative times this negative 1 makes that a positive 15 over 14. Subtract 15 over 14 from both sides and I get 42 over 14, and so y comes out to be 3. I now know z and y, so x plus 3 times y, which was 3, minus z times a negative 1. Working that out, I get 9. Whoops, sorry. That was supposed to be a 4z. Man, I am making this recording late at night, so it shows. My brain's not working. So I have a negative 4 times a negative 1. Gives me a positive 4. X plus, or a 9 plus 4 is 13, so x plus 13 equals 13, and so x equals 0. And I found my x, I found my y, and I found my z. All right, so that is plenty for now. Hope that went okay. Hope that one little mistake there with that 39 and 3 bit wasn't too much of a problem. Luckily, it wasn't way back at the beginning of that problem. As you can tell, there's a lot of steps in these problems. Whether we're doing a matrix or not doing a matrix for systems of equations, where there's 3 variables and 3 equations, there's a lot of chances for mistakes. So find some routine that allows you to be organized and meticulous, keeping track of all your different numbers, and good luck.